Let me tell you a story about AIs and how they actually work, because a lot of people, I think, don't really think about that, and it's time you become aware. When an AI writes something, whatever it doesn't write the whole answer, then gives it to you. So basically you send something, some work to you, question, or you request it does something. It doesn't answer with the whole thing. It starts writing word by word, actually token by token, but imagine it writes one word at a time, one. And it cannot read what it wrote before, and it has no idea what's coming up next. So it's like you are forced to write a essay, but you cannot read what you wrote before. And you just have to move forward and write next word and the next word and the next word. That's how LLMs actually work. And that's great. It's a proven fact that this is an efficient way to make the AIs think and work today. But we have a problem with transport, because in order for the output, this work that the AI did, the LLM did, we need to take it from the AI and give it to you, the user. And how do we do that today? Well, we use a block format. What is a block format? Well, a block format is a JSON file. Why might you need a JSON file? You may ask, why do I need that? Well, because most of the times a computer needs to process that information. And in order to process it, it needs to be in a structured format. And this structure is defined by the JSON format, because this is the one we're using today. There are also XML and YAML, but these are less used. All right, so why am I saying all this? Well, because JSON is very good. It was designed about 20 years ago, and it was made for web browsers. And it has a very important thing that it stresses out, meaning that it assumes that if they have one curly bracket wrong, curly brace wrong, or one square bracket wrong, or one comma wrong, it drops everything. So basically, imagine you have an envelope and you write your memo or whatever you want to do. This is the work the AI did. And if you don't close it well, you cannot read it. You receive the envelope, but because it has this error, you cannot open it. So you lose everything. You lose the work the AI did. You lose the time it took for the work to be completed. And you lose your money that you paid for the tokens to generate the compute, right? So this is a very serious issue, because the entire system is brittle. And what I mean by that? Well, imagine you have several agents, AI agents, that need to talk to each other. So agent A, B, C, D, and so on. All right. So in order to perform a task, each one of these agents needs to do something, and they communicate with JSON. So agent A produces a JSON, sends to agent B. Agent B produces an agent, sends to agent C, and so on. If one of these JSON payloads, these blocks, has an error, the entire pipeline stops, right? And you will lose a lot of information that was processed and paid for with time and money and of course compute, right? So that is a serious issue, and this is a total failure from one character. And this is the architecture we have today for AI. That is a serious issue. And I kept coming back to this particular thing, because I think that although JSON is very good for data storage and for transport, it is awful for orchestration. And we're forcing these line thinkers to put their data in blocks that are brittle. And my thought is, what if we change the format for which we communicate with AI? Now we have a solution for it. It's called YAWN. And this is a notation designed specifically for AI, where each line stands on its own, and it doesn't have any nesting like JSON has or the other block formats, and it is strongly typed. I will reveal this in the next videos, how this actually works. But think about it. One line one line is one thought. So the AI writes one line, you pack it, you send it. Another line, you pack it, you send. And the advantage of this particular approach is that architecture is very, very fast because you don't have to wait for entire document to be sent, to be received in order to start working with. So agent A starts doing the work and starts sending the responses to agent B. Agent B starts working, sends to agent C. So basically, you can have agent A still working and sending data, and agent D is already working here. So this is basically a real-time pipeline. Now, we cannot do that with block formats because in order for agent A to send to agent B the block, it has to be complete. Otherwise, it doesn't work. So this is like, while a line approach would be something like that, right? So yeah, that's the idea, and I actually know it works because I tested it. And yeah, you on.